and equivalent expressions. Okay, let's see the real world link. School supplies. Jordan buys 3 notebooks that cost $5 each. So we have 3, and each one is 5. So that's 3 times 5. He also buys 3 packages of pencils for $6 each. So now we have 3 at each one, $6. So 3 times 6. Write an expression that shows the cost of 3 notebooks added to the cost of 3 packages of pens. So we have 3 notebooks and 3 packages of pen. 3 notebooks at $5. Remember that this little dot means times, right? So we have 3 notebooks times $5 each, right? Plus, we also have 3 packages of pencils. 3 packages of pencils for $6 in total, correct? For $6 each. So, I know that if we were to solve this, and you guys know order of operation of PEMDAS, okay? PEMDAS, which again means we do parentheses first. Whenever we have an expression like this, we do parentheses first, then exponents. Multiplication or division can be interchanged depending on which one comes first. Addition and subtraction, again, can also be interchanged depending on which one comes first. Okay, you can do subtraction if it comes before addition. It doesn't matter, but we use what we call here commutative property. And it doesn't change the outcome. So if we were to do this, we would save the addition for after the multiplication. So we would multiply first, and we would have here 3 times 5 is 15, plus 3 times 6 is 18, and then we would have our total, right? And 15 plus 18 is 33. So he spent $33 in notebooks and pens. Okay. But now we're going to use distributive property. We know that we got notebooks that cost $5 each, right? And we also got packages of pens that cost $6 each. But we know that we got 3 of these and 3 of these. So we can just simply put the 3 on the outside, because we know that, let's say we were to add these two together, okay, 5 and 6 is 11. And then if we multiply that by 3, because remember, in PEMDAS, don't forget, there's PEMDAS right there. We do parentheses first. So we would do the parentheses first, figure out the amount of money in total that we spent times 3, because we bought 3 sets of each. Okay? So that would give us our $11 times 3, which would give us our $33. Right? We could also do it like this, where we actually multiply inward. We multiply the 3 times 5 and the 3 times 6. 3 times 5, 15. 3 times 6 is 18. Added together will give us again 33. Question 3. Evaluate both expressions. So we evaluated this expression, okay, which we did here again. It gave us $33. And we evaluated this expression where we did parentheses first, and then we multiplied with the 3, and it gave us $33. So evaluate both expressions. What do you notice? Well, I noticed that the expressions have the same value. Both of them have the same value. This, again, we're using commutative property here, because it doesn't matter if I flip the 6 or the 3 around, or the 5 or the 3 around. As long as we do the multiplication and addition first, and then addition after, we're going to get the same result. And over here we used the associative property, where we grouped the money and then multiplied it by the number of packages, because we bought 3 of each. Okay? Okay, place this smiley face right under your answer as a key answer. Okay, number 4. Suppose Jordan buys 5 notebooks that cost $3 each. It looks like we have here 5, right? Times 3. 5 times 3. And plus 5 packages of pens, so another 5 packages of pens that cost $1 each, times 1. Okay? Circle the expression that represents Jordan's purchase. Look at that. 5 times 3 plus 5 times 1. There it is. Okay, this one makes sense. Does this one make sense though? 5 times 3 times 5. No, because we're multiplying again. No, we're supposed to be adding the 2 that he bought. That's why it says and. What about this one? This one we use associative property. And what we're doing here, let's see, we bought 5 of both, right? 5 here and 5 here. So the 5 is being multiplied times the $3 and the $1. So yes, we're using associative property to group the money and then the number or the term, the number that we of each that we bought. So we multiply it. Yes, if I were to add these together, I get 4. 4 times 5 is 20. So this one also makes sense because this would give me $20. And this 5 times 3 gives me 15 plus 5 times 1 is 5, which would also give me $20. Okay, they both work. Number 5. Suppose Jordan buys 2 rulers. Okay, I'm going to circle the 2 rulers that cost $1 each. I'm buying 2 rulers and they each cost $1. And plus 2 folders. Okay, 2 folders plus 2 folders that cost $1.50 each. They each cost $1.50. Right, 1.5. Circle the expression that represents Jordan's purchase. Okay, 2 times 1 plus 2 times 1.5, 2 times 1 plus 1. There's 1. I see it right there, right? And then we can use associative property to put the money together. Remember, we have here $1 and then we have $1.50. We group the money. We have $1 and $1.50, and we bought 2 of each one. So we can use associative property to put the money together. We add the money and then how much of it, the term, how much of it we bought. There it is. Oops, wrong color. Okay, those two make sense. So what does this distributive property mean? The distributive property states that to multiply a sum or difference by a number, multiply each term inside the parentheses by the number outside the parentheses. As you see here, remember how we were adding the dollars first, and we were using associative property to put the dollar amount inside the parentheses? Well, we could take the term, the number on the outside of the parentheses, and multiply it into each one, and it would work. So then we have AB plus AC, okay? Or if we were to do it here, 4 times 6 is 24, and 4 times 2 is 8. So we would have, in total, 32 right there. Okay, that's what we mean by that. You could also do it with subtraction, okay? It's 3 times 7 is 21. 3 times 5 is, at this point, negative. It's negative 35. Negative 15. So we have 21 minus 15. Remember how in the previous lesson we were writing, for example, the expression 3 and we knew that we were multiplying the 3 and the n together. Once we figure out what the n was, let's say n equals 4, we would replace it, right? And we would put it as 3 times 4 equals 12, right? We knew that. What's happening now is that we actually have to figure out what n is. They're not making n just one value. They're making n multiple values. So what they're doing is they're adding a step, which means now n, instead of saying n equals 4, they're telling us, no, n equals a value that we don't know, such as x plus 2. Okay? Or we could say x plus 3, so that you know that x is something different. Like at this point, if you knew that it should give you 4, you know that x is 1. But they're not telling us. They're telling us only part value of what n is. So that's why it ends up looking like this. 3 parentheses x plus 3. So what do? Well, we use distributive property to multiply 3 times x and 3 times 3. So now our equation looks more like this. Sorry, I'll move this out of the way. Our equation will look more now like 3 times x is 3x, and 3 times 3 equals 9 plus 9. And that's as far as we can go, because I guess we can use distributive property one more time, and we could write 3 plus 9 in parentheses and x on the outside. It would be the same, it would still equal the same thing. But that's what we're trying to show you here, that essentially we're doing the same thing we did in the first lesson, or in the lesson previous to this one, but we just have to take one additional step to figure out what the variable is. And as you can see here, let me throw all this out of the way, as you can see here, that's what they're telling us about. They're telling us to draw models. So here we have x and 2 values, so it's actually going to look like this. No, x plus 2. This is x plus 2 of them. And now we have x again and x again, plus 2 and plus 2. So this could actually be, this is repeated twice. So we can write it as we have our x plus 2, which we already see right there, right? We see our x right there, x plus 2, and then we have another x plus 2. So why not just write this expression in a parentheses like that, and we say that it's times 2, as you can see right there, right? That it's times 2. Okay, what about here? What about here? It's the same thing. Now we're just grouping them. Now we're going to say that it's x, right here, you see that? But it's s squared, it's 2 of them. And how many of these do we have? 4 times 4. We could also group it like that, couldn't we? I'm sorry, I'm realizing that I multiplied. No, it's not multiplication. It's actually, if I can squeeze it in here, if I can squeeze in there, it's actually addition, because we're just adding everything that's in this box. So it's x squared plus 4. I think we're ready to try some questions. If you have any doubts after you watch me do it, you can also just reflect on example 1 so you can see how they use distributive property, okay? But let's see. I have 5. Let me zoom this in a little bit more. We have 5 times negative 9. 5 times negative, a positive times a negative is a negative. That's going to give me negative 45. Plus 5 times 11 is 55. You see? And then when we solve for that, I simply get 10. Okay? Because this is like writing it. If we were to rewrite it so that it makes more sense, so it's essentially 55 minus 45. Okay? B. 7 times 10 is 70. And then 7 times negative 5 is negative 35. Right? And when we do that, 70 minus 35 is just 35. Okay? And now we have 9 times 12. It's 108. 108. And minus 9 times negative 8 is 72. Negative 72. And when I subtract those two, I get 28. 4 is 36. 36. There we go. Example 2 is just another demonstration of distributive property, where you multiply 4 times x, it gives you 4x, and 4 times 7 is 28, so it ends up being 4x plus 28. This is what they asked to simplify it, okay? Here we have 6 times p is 6p, and 6 times negative 5 is negative 30, so you have 6p times minus 30, okay? Here's some more examples. For number 4, you see that we're going to simplify and simply use distributive property of negative 2 times x is negative 2x. And negative times a negative. So negative 2 times a negative, remember, same symbols equals positive. Negative times negative equals positive 16. Number 5. Okay, essentially the same concept. 5 times negative 3 is negative 15x. Negative 15x. 5 times 7, positive 7, times 7 is 35, 35y. There you have it. And now for 6, we're going to throw a curveball at you, and we're going to use fractions. Remember, when you multiply a whole number times a fraction, you get the fraction of that number. So you know what 1/3 of 6 is. 6 is divisible by 3, and it goes 2, 4, 6, right? So 1/3 of 6 is 2. So we multiply 1/3 times x is going to be 1/3 x. And then 1/3 times negative 6, you're going to get 1/3 of 6, which is negative 2. Of negative 6 is negative 2. And there it is. If you have any questions about this, please ask in class. Okay, if you felt